Hello, wonderful math students, and welcome back to another lesson on fractions. At this point, we have seen 2 lessons on fractions so far. We had our introduction to fractions lesson, and then after that we had a lesson on equivalent fractions. We're going to start getting into the actual math operations today. So the first thing we're going to look at with the operations is how you add and subtract fractions. That'll be the topic for this lesson. Before we get into adding and subtracting fractions, remember we decided this week we're going to start including some review questions at the beginning of these, just to help make sure you're not forgetting all this wonderful math you're learning. The first question is, the store is selling bags of Hershey Kisses for $6. Each bag has 60 Hershey's Kisses. If Maria wants to buy 7 bags of Kisses, how much will it cost? All right, this one had extra information we don't need. We need to know the cost of each bag, and we need to know how many bags she's buying to figure out how much it would cost total. We don't care about how many are in each bag. To find the total cost, you would multiply the cost of one bag times how many bags she's buying and get that total cost is $42. The other question asks, use an inequality sign to compare the amounts. To answer this one, first you need to know what an inequality sign is. We have 2 inequality signs, the less than sign and the greater than sign. To know which one I want to use here, I need to know what each side equals. This left side here, if you've got 2 numbers next to each other in parentheses, that is multiplication. -3 times -4, well, 3 times 4 is 12, and a negative times a negative is a positive. On this right side, we have -3 minus 4. I see they are both negative. Since they're both negative numbers, that means we want to add those 2 numbers together and keep that negative sign. For an inequality sign, if I'm reading it from left to right, I want it to say 12 is greater than -7. It's greater because it's positive. Positive numbers will always be greater than negative numbers. So we would want to say 12 is greater than -7. That would be the inequality sign we use. Now that we've got those brain juices flowing, we can go ahead and jump into our work today on fractions. Our objective for this lesson is that by the end of it, you can add and subtract fractions. And with that, we will get started with our first question. The first thing we're going to look at, we're talking about pizza again. It's just so common to talk about pizza when it comes to fractions. And this question says, Mariko ate 3/8 of a pizza. Trayvon ate 2/8 of a pizza. How much total pizza did Mariko and Trayvon eat? Now, before we answer this question, I think pausing for a moment and thinking about what information it's telling us, it will be helpful. So the first thing they told us is that Mariko is eating 3/8 of a pizza. I just want to pause and think about, what does that look like? Well, I've gone ahead and given us a circle that's divided up into 8 parts. If he ate 3/8 of a pizza, he means he ate 3 of those 8 parts. So if I wanted to draw a picture of what he ate 1, 2, 3/8 of the pizza. He ate that black part right there. Now it tells me Trayvon ate 2/8 of a pizza. Same idea. I've got that same shape pizza over there, still cut into 8 parts. He ate 2 of those 8 parts. So that means, just to keep it consistent, he ate these 3. So I'm going to start here and say he ate 1, 2, 8 of the pizza. He ate 2 out of those 8 parts. Now that we've got a picture, I'm going to have you go ahead and try answering the question, how much total pizza did Mariko and Trayvon eat? Well, to answer this question, really what we're trying to do is figure out how much total pizza they ate, which means we want to put those 2 amounts together. So we've got, remember, adding is finding the total of something or putting 2 amounts together. So if I wanted to add these 2 fractions, which is really what the question's asking us to do, we just have to put those 2 pictures together. It said Mariko ate 3/8 and Trayvon ate those 2/8 of a pizza. So together they ate 5 of the 8 slices of pizza, or 5/8 of the pizza. Now I think it helps to look at this picture first because I want you to notice what you're doing with the numbers. If I didn't give you the story about pizza, if I just gave you 3/8 plus 2/8, what would we have to do to get that answer? When you add, do you add the numerators together? Remember, numerators are the top number. So when we're adding fractions, do we add those numerators together? Well, yeah. I want to say he ate 3 slices out of the 8 slices, and the other guy ate 2 of the 8 slices. So together, they ate a total of 5 of those slices. We do want to add those numbers. When you add fractions, do you add the denominators together? Well, the denominator to those bottom numbers, notice 8, 8, it's still 8. We are not adding those denominators together. For the story about pizza, when you look at it with the picture, it makes sense. The first guy ate 3 slices, the second guy ate 2 slices, but there's still a total of 8 slices. I'm not going to add 8 and 8 and say 16 because the total amount of slices that pizza's cut up into is remaining the same. It's not changing. At the end of the day, it's still out of 8 slices. That is going to be important, especially when we look at some problems that aren't about pizza. It's just a straight addition or subtraction problem. We've got one more that we're going to look at. This was an example of an addition problem. We've got another example we'll look at. This one says Ranish's gas tank is 3/4 full. She uses 1/4 of her tank when she drove to Bloomington. How full is her gas tank now? I'm going to have you go ahead, try this one. All right, well, if I do the same thing we did last time, let's pause first and just think about what this looks like with a visual before we do any subtracting. She is starting off with 3/4 of a gas tank. So that means if this was the tank, she has got 1, 2, 3 out of the 4 parts full. So the black part represents the gas. Now it tells us she used 1/4 of her tank. If you're using that gas that's emptying out of the gas tank, I guess that's gas you're using, it's gas you want to take away. So we want to subtract out 1/4. We want to take away 1 of those 4 parts there. When you do that, picture taking out that 1 square there. Well, if I take out that 1/4 she used, it's leaving these 2 parts here left. And that picture I've just drawn is 2/4. Similar to adding fractions, when you subtract fractions, notice we are subtracting those numerators. I am doing 3 minus 1 and getting 2. But just like last time with adding fractions, that denominator, 4, is staying the same. That gas tank is still divided into 4ths. Now we've got 2/4 right there, but that is not the final answer. Do you know why? Well, it goes back to what we learned in yesterday's lesson about equivalent fractions. When you are looking at a fraction, for our final answer, we want to make sure it's simplified. Now, if you were looking at this picture and maybe not saying 2/4 to yourself, maybe you were thinking a different fraction, you would be right. This is 2/4 because I've got it divided into 4 parts and we have 2 of the 4 parts. But another way to think of this right here, well, look, that's half of the tank. Remember in our lesson yesterday, we learned how you simplify fractions? If I have a fraction like 2/4, I want to check to see if I can simplify it by checking to see, is there a common number you can divide both 2 and 4 by? So as I'm thinking of numbers I can divide, I notice I can divide both of those numbers by 2. If I do that, if I divide both 2 by 2 and 4 by 2, 2 divided by 2 gives you 1, 4 divided by 2 gives you 2, and there we go, we've got 1/2. If I look at the picture, I can see this is 1/2. If I just redraw that and only divide it into 2 parts, she's got half of a gas tank left. So to answer the question, how full is her gas tank now? We could say it is half full. Before I move on, I've got one question for you to think about, and we've kind of been talking about it as we've gone through these problems. It's usually clear to people why we want to do the 3 minus 1 to get that 2. But when fractions are added or subtracted, why does that denominator, that bottom number, why does that denominator stay the same? Well, if we go back to that pizza problem we had talked about, that denominator is telling you how many slices are in that total pizza. That was never changing. We were just saying he ate 3, he ate 2, but the pizza was still cut up into 8 slices. Same idea here. That 4 is not changing because our gas tank is always been divided into 4 parts. The total parts remains the same. Even if you're adding or subtracting parts together, how many total parts are in your shape or whatever it is remains constant. That part's not changing. So that is why the denominator stays the same. These were my 2 examples. I've got some for you to try now. The first one looks like this. We've got 11/12 minus 3/12. Go ahead and try that now. For that, you should have subtracted your numerators, your 11 and 3, and got an 8/12. Did you remember to simplify? Hopefully. You want to simplify that. There's a couple different things you could do. You might have chosen to divide by 2. If you do that, that's perfect. You can divide both those numbers by 2. 8 divided by 2 is 4. 12 divided by 2 is 6. If you chose to divide by 2, though, you are not done because you can divide more. You can divide both of those numbers also by 2. And that would leave you with our final answer of 2/3. Back here, your other option was you could have divided them both by 4. And that would have taken you immediately to that final answer. So that is one practice problem on subtracting fractions. There is one more for you. This other practice problem says KG added 3/4 a cup of sugar to her cake mix. She decided it needed to be sweeter and added another 1/4 a cup. How much total sugar did she add? All right, so let's check what you've put down. For this one, I have this beautiful picture. I made this picture of measuring cups. If we drew what they're telling us here, it's saying the first thing she did was she added 3/4 of a cup. I've already got this broken up into 4 parts. We've got part 1, 2, 3, 4. So she filled it. That would be 1/4, 2/4. She put that much sugar in. She put in 3/4 a cup of sugar. She decided it needed to be sweeter, so she added another 1/4 a cup. So that would be that right there. Well, if you put those together, we've got 3/4 here plus 1/4 here. That's going to give you 1/4, 2/4, 3/4, 4/4. So we're left with 4/4. Now, part of the reason I'm using this picture to talk through this problem is if you said 4/4, you're not wrong, but that's also not what you would hear if you were in a kitchen measuring this out. You wouldn't say 4/4. If you simplify and divide both of those by 4, that gives you 1 whole. We had seen this in that last lesson as well. We said if that denominator is 1, it means it's not a fraction. It means you have 1 whole cup. And I've got this picture here showing you if you actually filled it up to that point on a measuring cup, it wouldn't say 4/4 of a cup. It would just say 1 cup. So our final answer is she added 1 cup of sugar. Now this was the first part of the notes. You might have noticed all of these problems I gave you so far have something in common. And if you have not noticed, let me show you what this next part looks like. So the other half of this lesson is on problems that look like this. How is this problem different from all the other problems we've done so far? Well, this one here is different because if I look at these fractions, I see the denominators are different, which was not the case before. Every single other problem we've done so far, they've been the same. That's not always going to be the case. So for example, I've got the same people, well, not the same pizza, but the same idea, except now I've changed it to Mariko ate 1/3 of a pizza and Trayvon ate 1/6 of the same pizza. And so the question is, how much total pizza did they, I don't know where the word eat went, but that is the question. How much total pizza did they eat? Well, looking at this picture here, before what we did was we just added the numerators and kept the denominator the same. There's a couple problems with that in this example though. I could add the 1 and 1 together, but which denominator would I keep? I don't know. The other problem with that is look at the amount of pizza they ate. He ate 1 out of 3 slices of pizza. He ate 1 out of 6 slices of pizza. I could say they ate 2 slices of pizza, but they didn't eat the same amount because he ate 1/3 and he ate 1/6. Those slices aren't the same. This kind of goes back to what we had said in our intro to fractions lesson. When you're talking about fractions, especially if you were talking about adding or subtracting fractions together, you need these parts to be the same size. I can't say like, oh, well, he ate 1 slice and he ate 1 slice. I could, but it's not the same thing because they're different size slices. So in order to add these together, we need to change this problem so that they are the same size, and that way I can just add up all those slices. Now looking at the picture helps because I see what I can do. I could come in here and say, well, instead of saying he ate 1 really big slice, I could change this pizza to be cut up the same way this pizza was. I could come in and say, well, let me just cut all the way across, cut all the way across, all the way across. Now it's cut the same way this pizza is. And I can see, okay, his pizza is in 1, 2, 3, 4, 5, 6 slices, and he ate 2 of 6 slices. His pizza is also cut into 6 slices, and he ate 1 of the 6 slices. Now that they're the same, now we would be able to add them up together. Now it's easier to see if you have a picture, but what if I didn't have this picture? How would I do that? Well, it goes back to what we learned yesterday with equivalent fractions. What we've been saying this whole time is that if I want to add these fractions together, I need the denominators to be the same. And notice in the picture, I changed the one with the smaller denominator to look like the larger denominator. I changed the fraction with the smaller number here to look like the bigger one. This fraction stayed the same, but I need to change that smaller fraction to a fraction that has 6 as the denominator because we want these numbers here to be the same. In order to do that, all I have to do is find an equivalent fraction to 1/3 that has a denominator of 6. We looked at problems like this yesterday. I was giving you problems that looks like 1/3 equals what over 6. Do you remember what we had to do to change this fraction to a fraction where the denominator was 6? Well, because I'm making the numbers in the fraction larger, we were using multiplication. We would find what common number we have to multiply 3 by to make it 6, and use that same number to multiply 1. So if I look at this, I would ask myself, well, 3 times what number equals 6? Well, I know 3 times 2 equals 6. Since I multiplied the denominator by 2, I've got to do the same thing on top and come in and say 1 times 2. 3 times 2 is 6. 1 times 2 is 2. What I've just found is that the fraction 1/3 is the same as the fraction 2/6. It's real easy to see that since we've got the picture, right? I changed 1, 2, 3, 4, 5, 6. I changed this picture into 2 out of 6 slices. But remember, it originally looks like this. It originally looked like 1/3. Same amount of pizza, just cut up a different way. The reason we want to do that is because now it's the same as what we did before. I could go ahead and add 2 6 plus 1 6, and I would get, well, 2 plus 1 gives me 3. And remember, we learned from those past problems that the denominator, that 6, will stay the same. It's going to be 3 6. Now we could say the final answer is 3/6, but there's still something there we can do. I can simplify that fraction. If I look at 3 and 6 and ask myself, what's the number that goes into both 3 and 6? I notice I can divide both of those numbers by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. And we're left with the fraction 1/2. Together, they ate a total of 1/2 of that pizza. If I went back to that picture we had, picture putting this slice of pizza over here. He ate these 2 slices. He ate this slice right here. So look at that circle. They ate half of that pizza. They ate 3 out of the 6 slices, or half the pizza. So this was an example where we had a picture. We were able to work through it using the picture and some of the math. I've got to erase this first. And then I've got a note that says fractions must have the same denominator to add or subtract. That's what we were doing that last one. We changed 1/3 so that it had the same denominator, had a denominator of 6, just like the other fraction. How did we do that? So if I don't give you 2 fractions that have the same denominator, what could you do? Well, you can find an equivalent fraction. We found that equivalent fraction by multiplying here. We found what number we needed to multiply the one fraction by to have the same denominator as the other fraction. I've got one last example. This one is about chocolate. Why do we use so much food with fractions? In this example, we've got Deja has 7/12 a bar of chocolate. She uses 1/4 of the bar to bake some cookies. The first question asks, how much of the chocolate bar does she have left? Go ahead and try. Well, we've got 7/12. 7/12 looks like me coloring in 7 out of these 12 squares. So 1, 2, 3, 4, 5, 6, 7. Now it's telling us she used 1/4 the bar of chocolate. So she's taking away 1/4 of that bar. She's taking away 1 out of these 4 parts. If I do that, if she's taking away this 1 bar, imagine me taking away this 1 bar. That's going to leave you with 4 of them. So she's left with 1, 2, 3, 4. So I've got a picture of what's going on, but what's the math look like? If I gave you 7/12 minus 1/4, just like in that last problem, I cannot do that subtraction until those denominators are the same. So looking at that, also like last time, I want to change the fraction with the smaller denominator and make it look like the fraction with the larger denominator. So I want to come in here and say, well, this one can stay the same, but I want to change this fraction so that it has the same denominator. The way we do that, well, ask yourself 4 multiplied by what number gives you 12? Well, 4 times 3 gives you 12. Whatever you do on the bottom, you got to do here on the top too. So we said 4 times 3 gives you 12. Do the same thing with the 1. 1 times 3 gives you 3. And now we have 2 fractions that have the same denominator. Now we could go ahead and subtract. You wanted to do 7/12 minus 3/12. 7 minus 3 gives you 4. And 12 minus 12 gives you 12. I had already drawn the picture of my answer. We've got 1, 2, 3, 4 shaded in out of 3, 6, 9, 12 total parts to that rectangle. Now, the last thing I want to show is how you go from 1/4 to 3/12 on that picture. Remember that picture we shaded in 1 out of the 4 sections. If I change this, kind of like I did with the pizza, so that it was divided up into 12 parts, could do it the same way this one is, and come in and say, now there's 1, 2, 3, 4, 8, 12 parts. 1/4, that one bar there, is the same thing as 1, 2, 3 out of 3, 6, 9, 12 parts, which is what we did over there with the math. Done a lot of math. I've done a lot of pictures. We got 4/12. That is not the final answer because similar to those other ones, there's something you can do to simplify. As you're looking at that, you want to think of a number you can divide both 4 and 12 by. Maybe you're thinking 2. 2 would work. There's a larger number. You can divide both of those by 4. I'm going to use that 4 to simplify. I'm going to say, let me divide both of those by 4. When I do that, 4 divided by 4 is 1. 12 divided by 4 is 3. Our final answer is she has 1/3 of that bar of chocolate left. There's a second part to this question. So we just figured out Deja's got 1/3 of a bar of chocolate. Part B tells us Lillian has half a chocolate bar. Who has more chocolate? You can show your reasoning with numbers or a picture and use an inequality sign to compare the amounts of chocolate. So let's start first with the question, who has more chocolate? Deja with 1/3 of the chocolate bar or Lillian with half a chocolate bar? Well, this goes back to what we did in that first lesson on comparing fractions. There's a couple different ways you can do this. Since I'm comparing with a half, half is usually like the one fraction out of all the fractions we have that people are the best at picturing. So picture in your head half of something. Would 1/3 be more or less than that? Half is right down the middle. So if I wanted to draw a picture, here's my chocolate bar. She's got half. What does 1/3 look like? Well, 1/3 would mean it's broken into 3 parts and you've only got one of those 3 parts. That's going to be less than half. So it means if I put it into 3 parts, if you've only got one, that's less red than up here. That means it's less chocolate. So just from that, we can figure out that Lillian has more chocolate. So I'm going to say Lillian has more. Other ways you can do it, you can compare them to a half, you can use a picture. You can also use the fact that as a denominator the number gets bigger, the actual fraction gets smaller. So 1/2 is bigger than 1/3. 1/3 is bigger than 1/4. 1/4 is bigger than 1/5. As that denominator, as that bottom number gets bigger, the size of the fraction gets smaller. These are all ways you can figure out this first part. Now notice the question has a second part that says use an inequality sign to compare. If I've got 1/3 here and 1/2 here, what inequality sign would I want to write there? Well, the order I've got it written in, I want to say 1/3 is less than 1/2. So I would want to use that less than sign there. These are all of my examples. We've got these 2 for you to try. Let me clean up the board. Okay. The first one says 2/3 plus 9/21. All right. To add those, you would want to multiply this fraction here by 7 to make the denominators the same. This says 9/21. Over here, 7 times 2 is 14. 3 times 7 is 21. Then you would be able to add them together and get 23/21. I know I can't simplify because there's nothing you can divide both of these by. There's no common number you can divide by. What about that second one? 15/24 minus 1/4. Here you'd want to multiply that second fraction by 6. That way the denominators would both be 24. 1 times 6 is 6. 4 times 6 is 24. Here when you subtract 15 minus 6, it gives you 9. So we get 9/24. This time you can simplify. If you're having trouble simplifying, just start going through the numbers. So ask yourself, can I divide both of them by 2? No. You can divide 24 by 2, but not 9 by 2. Can I divide them both by 3? Well, 9 divided by 3, yes. 24 divided by 3, yes. And kind of work your way through all the possibilities. If I divide by 3, 9 divided by 3 is 3. 24 divided by 3 is 8. And that would be our final answer because there's nothing else you can divide by. One last one. This last one says, there you go. Karina ran half a mile, took a break, and then ran 1/6 a mile more. How far did she run? Show your reasoning with numbers or a picture. You cannot give me a picture, so give me some numbers to support your answer. Okay. And then the second part says, Destiny ran 1/10 of a mile. Who ran further? Show your reasoning with numbers or a picture. Again, you are at home on a computer. You can't give me a picture, but you can give me numbers, so try that. All right, that is the last thing for this video. Thank you so much for watching. I'm hoping you're feeling better about fractions. If you're not, remember, we love seeing you for tutoring. Please show up for tutoring. We go into education because we want to help people, so you are not bothering us if you show up for tutoring or come into the school on a Friday for tutoring. We want to help you, and we know it's really hard right now when you're at home, so please reach out if you're struggling with it. I know not everyone starts off with fractions being their favorite thing, but we can get you a little closer to it being your favorite thing. So please reach out to me if you need any help with this. Hopefully you're feeling better though after watching this video. Thanks so much for watching. Bye.